Hello everyone. Today I am going to teach you evaluation of ointment. So first of all, I will let you know what is ointment and what kind of testing is performed on ointments to check its quality. So this topic comes under the uh, branch of quality management of pharmaceutical products, and here we will study the evaluation of ointments. How will we evaluate the quality of ointments? So what are ointments? Ointments are semi-solid intended for external application on skin or on mucous membrane. So these are the semi-solid products which are applied on either on skin or on the mucous membrane. Mucous membrane like somogel is used, and skin like physiodic acid or fudic. Or ointment are also defined as semi-solid products externally applied on the skin or either on the membrane, and its composition is like contain less than 27% of the water and volatile oils and more than 70% of hydrocarbons, waxes or polyols as vehicles. So it contains like less than 20% of water and more than 50% of the vehicles like hydrocarbon, waxes or polyols, and provided emollient effect, protecting effect, or lubricant effect. So these are the basically definition of the ointment. So ointment are intended for topical use. They are applied topically. They are not for oral use. Either they can be applied on the mucous membranes, and mostly they are used topically. They are used to provide protecting or emollient effect, like either they are giving the protecting effect or either they are giving the soothing effect on the skin, or carry medicaments for treating certain topical ailments. Uh, Basically, we prepare base for the ointment, and we can add any medicament, any active ingredient in the base of the uh, uh, ointments, which can be used for any topical ailments like dermatitis and any other topical ailments. Mostly steroids are used on the topical preparations. So there are basically 5 bases for the ointment. We will study next in the next slide. So any greasy or oily semi-solid preparation, usually medicated, that can be applied externally to the skin in order to either heal the skin or either soothe the skin and give any protecting effects, is an ointment. So this basically it's a semi-solid preparation which is applied externally on the skin. So basically there are the 5 basic classes of the ointment bases. These are the bases. We can add any active ingredient, any medicament on this basis to prepare any medicated ointments. But there are the 5 basic um, ointment bases on basis of their physical activities and pharmacokinetic effects, which is oleaginous basis, which is also known as hydrocarbon based, absorption based, water in oil emulsion ointments basis, oil in water emulsion ointment basis, and water soluble or water miscible basis, which is the best ointment base from which the active ingredient or medicament is like easily released हो जाता है. It get easily released from the base. So on the basis of the composition, medicaments are these are divided as like oleaginous ointment base, which is oleaginous compound in composition. It is a water content anhydrous. Its water content is anhydrous. It is hydrophobic. Its spreadability is very difficult. It is easy to spread over the skin. It is non-washable, and its stability is poor because hydrocarbon are better. If we study about its drug incorporation potential, so mostly oil-based drug easily solubilized in this oleaginous basis. Drug release capacity is very low, and its occlusiveness is very greater. It do occlude, it forms locules in the tubes and uses as a protectant. Emollient, it can be used as emollient and can be vehicles for other drugs. Then is the absorption ointment base. It is oleaginous base, and we add water in oil surfactant in it. Water in oil surfactant. It is also anhydrous in nature. It is hydrophilic. It is difficult to spread also. It is non-washable also. It is oil poor hydrocarbon better. And it get mostly solid oils and aqueous solutions in it. And drug release capacity is for greater than oleaginous basis, and it forms all occlusions, and it is used as protectant, emollient, vehicles of aqueous solutions, solid and non-hydrolyzable drugs. Then comes the water in oil emulsion, that is oleaginous basis, and we add water. That should not be greater than 45% water in water, and water in oil surfactant whose HLB should not be less than 8. It is hydrous in nature, it is not anhydride. It had water. It had water. Its composition had do water. It is hydrophilic in nature, moderate to easy spreadability. It's just far more better spread. Its spreading property is far more better than the absorption base, ointment base, and oleaginous ointment base. It is washable, but poorly washable. It is unstable, especially with the soaps and natural colloids. Sorry. The drug which is mostly get in it is solid oils and aqueous solution in very small amount. Its drug releasing capacity is better, and it do occurs, but not so much. It is used as like cleanser and emollient, cream, vehicles for solid liquids, and non-hydrolyzable drugs. Then comes the oil in water emulsions, ointment bases. These are basically the oleaginous basis, and we add water in it, and the water content is far more greater than 45% water in water. And oil in water surfactant. Here, oil in water surfactant is used now, and here is water in oil surfactant is used, and here in the oil in water surfactant is used. So HLB should be 9%. Basically, the basis of a base is oleaginous base, but we add water, and we add oil in water surfactant in oil in water emulsion, and water in oil emulsion surfactant in water in oil emulsion. So basically composition is water and oleaginous base, is only the surfactant nature is converting the base from water to oil and oil in water. So it is hydrous, and water affinity is hydrophilic. It is loving to water because it has water content greater than 45% water in water, and its spreadability is greater because it has water in it, and its washability is good because it has water in it, and it is like and like rule. And its stability, it is unstable, especially in presence of soaps and natural colloids and non-ionic batters. And the drug mostly incorporate in it is solid aqueous solution in small amount. Its drug release capacity is good, and it do not form occlusions. It emollient, vehicles, and solid and hydrolyzable drug are mostly used in it. Then comes the water miscible ointment, which is the most widely used basis, and it is a polyethylene glycol PEGs base, which is used widely. It is anhydrous and hydrous. It is hydrophilic. It has greater spreadability, best spreadability in property. It is washable, and it is very stable, and that's why widely used. And the drugs are mostly solid aqueous soluble solutions, and it is very good in drug releasing potential. It does not form any occlusions. It is the best base which can be used, and it is mostly used as drug vehicles for large number of different active APIs, active ingredients. So the quality control tests which we perform on the ointments are: first, appearance and color. It is a USP indicated test. Then weight variation test, and the standard we use are the BP. Minimum fill means how many minimum quantity of either ml or milligrams are filled in the ointment tube. Then particle size determination, BP, particles of the medicament in it. Particle size determination according to the BP standards, microbial content test according to the USP standard, metal content in ophthalmic ointment according to the BP standard, and sterility test. 7th test is potency or content uniformity test. The content and the weight filled in each tube should be uniform, and then the viscosity test, the viscosity of each tube medicament should be same, leakage test, and the homogeneity test. First of all, we will see about the appearance and color test. The procedure is very simple for this test. Simply, we just take a tube in which the ointment is filled, and then what we do, we examine the color and appearance of the medicament or the tube which is filled in the tube under the tube or under any light source. Acceptance criteria or rejection criteria is very simple, and transculent sample is acceptable, which are transculent and the light can pass through them, and the color should be like from colorless to yellow. Then comes the homogeneity, that all the medicaments or any particles which are present in the our ointment are of same size. Homogeneity is like particle size uniformity. So content of ointment placed in a glass slab, like we produce a smear of ointment on a glass slab and spread a thin layer of the ointment on the glass, and then under the glass slab we put a light source bulb, and we observe the particle size or the homogeneity of the particle size. Ointment is homogeneous and there is no granules or no accumulations is present in the tube ointment, and that pass the homogeneity test. Then comes the weight variation test or minimum fill. How many ml or mg of the bases or the medicament is filled in the tube, ointment tube. Test is applied for those containers which are either 150 gram or ml of the preparation, not minimum or greater than that. So what we do, we select at least 10 filled container, remove their label, so the weight of label do not interact with it, and then we weight them individually. We weigh 10 filled container, and then we empty the containers, and then we again weigh the empty containers individually, and then we get a difference of the filled container and the empty containers, and then we take the average of that container's weight, and if the average of that container lies that is mentioned on the label, then our ointment tubes or either our ointment containers fulfills the weight variation test or minimum fill test. And there is some standard which are applied according to the USP, which is like average test for 10 container, which should not be less than the label amount. The average should not be less than the labeled amount, which is labeled on the container label. It should like near about on it. It should not be far more greater. It should not be far more less. It should be near to the average weight. Performance in two stages, like S1 stage and S2 stage. In S1 stage, we take 10 units on 10 ointment containers, and in S2 stage, we take like 20 to 30 containers. So first, these are some USP standard which are mentioned in the USP. Sample size of, if the sample size is equal to or less than 60 milligram, then if we take S1 standard one and we take 10 units, then the weight of single container should not be less than 90% of the label amount. The single container should not be less than 90% of the label amount. The container should be 90%. Like it should be, if the labeled is like 10 gram, then it should be like 90 gram, 91 gram, 93, 95, 96, 99, or 100 gram. It should be like it should not be Joanna. It should the content of any single container should not be less than 90% of the container. It can't be 89, it can't be 85, it can't be 75%. It should be within the range of less than 90%. And if we take the S2 standard, in which we either take 20 or 30 containers and empty them and weigh, and the average we find the average kind of weight. So it should, in which we take at least the 3 units should be less than 90% of the label amount. The minimum standard is 3 containers should be less than 90%. And if we take a container which is either like 60 grams and 150 grams, so note a single container should be less than 95%. It should be like 96 97 grams, 98 grams, or 90 or 100 grams. And the minimum standard is like 95%, less than 95%, not acceptable. Less than 95% is not acceptable. Then the label amount. And if we take like S2, in which we take 20 or 30 containers, not more than 1 unit should be less than 95% than the label amount. These are the set criteria. Then the next step is potency or content uniformity test, in which we we take individual monograms. It depends upon the individual monograms. We perform the individual monograph test as mentioned on the individual drugs or individual basis. But we take at least 20 units individually. If the test failed for the 10 individuals, then we take 20 containers for the test. The test performed is dependent upon the individual monogram. It could be trimetric and assay. It can be titration. It can be HPLC. Any monogram test, potency, content uniformity test that is mentioned on the assay of that individual monogram of that drug or medicament. It depends upon the medicament that is present in the ointment. Conduct the assay as amount of the material that drains the individual container. The next test comes, the acceptance criteria for the content uniformity is very simple. For those 10 doses units, not more than one individual content should be outside the 85% or 115 of the average level. Like if the container is mentioning 30 milligram of the active ingredient, it should have within the range of not more than one individual should have more than or less than 85% of 115% range in between, and not a single individual should be outside of or within the outside the 75% or 125% average level amount. And if we take 20 more units when the 10 doses unit are rejected, then we take 20 units doses or either 30 unit doses. Not more than 3 units are outside 85 and 115 range. As mentioned, average label amount, and not outside 75 and over 25% average content. It is the limit. No one should be outside the 75 and 125 average content. Then comes the particle size determination, in which we find the particles and we use microscope for this purpose. So the procedure is very simple. First, we take the ointment and then we dilute the ointment in a equal volume of the glycerol or either paraffin oil. Then we mount that is mentioned, whatever the sample solution we have prepared according to the glycerol or liquid paraffin that is mentioned on the specified monogram of that medicament or ointment. Then we mount the dilute sample on the microscope, and then we illuminate the microscope with the help of the light, and then we count the number of particles with diameter above or below the specified monogram, and if either the particles size are within the range or not. Compare the percentage with the official limit. There are the official limit that are mentioned in the BP or USP, and we follow them. Like if the particle size is of the medicament or any ingredient is 10 microgram, which is quite smaller, then there should not be 12 particles per ml. Like if we take 1 ml of the drug on the microscopic slide, then not more than 12 particles should be observed in 1 ml. And if the particle size is like greater, like it's 25 microgram, less than 25 microgram, or greater than 25 microgram or equal to 25 microgram, then not more than 5 particles per 1 ml. And if the particle size is far more greater and it is 50 microgram, less than 50 microgram, greater than 50 microgram, or equal to 50 microgram, it should not be 2 particles per ml. So that is very simple, and it is we have to memorize this standard, or even we don't have to memorize this standard, because these standards and these ranges are given in the BP and USP official compendias. And then comes the microbial content or sterility test, which is very important for the ophthalmic preparation, especially because if we are preparing any optical preparation, then we don't have to so conscious about the sterility of these ointments. But if any preparation is ophthalmic and which is applied on the mucus or any ophthalmic its preparation, then we have to consider the microbial content sterility test. So topical applications and topical preparation do not require so much sterility. either if they are applied on the acne, then the like the betamethasone valeriate ointment, it should not have Staphylococcus aureus or Pseudomonas aeruginosa, because these microbes do cause the uh, uh, acne, and this ointment is specially used on the skin when there is a crack on the skin or any for the acne. So these microbes should not be present in these tubes. uh, but do we have to consider sterility? But mostly we do not consider the sterility for the tropical applications or the topical applications, but we do have to consider about the betamethasone. It's a special example. It is an exception. So there must be separate standards. So there is a separate standard for the microbial content for the ophthalmic preparation and the topical preparation. These are the standard basic standards which are given in the compendiums, separate for the ophthalmic preparation and separate for the topical preparations. For so they must meet the acceptance standards. So microbial for sterility of ophthalmic semi-solid should be free from any anaerobics and aerobics bacteria. Different medias for the use to check the aerobics and anaerobics bacteria sterility test. Sterility test is applied for the product to be sterile, such as ophthalmic preparation test performed when mentioned in the official monograms. We can either use direct inoculation method or we can use membrane filtration method. So one by one we will study about the membrane filtration method. So in the membrane filtration method, we take the ointment and we produce 1% solution in the isopropyl myristate, and then we allow it to pass through cellulose nitrate filter of pore size not less than 0.45 micrometer. And if important, if we have to increase the process of filtration, membrane filtration, we can do use vacuum suction or pressure applied on for the filtration to fasten the process of filtration. Membrane filtration is washed 3 times with the 100 ml of the any sterile diluent, and then we are rinsing the fluid with it and transfer this aseptically on the media. Okay. We applied it on the media, and we can either use a fluid thioglycolate, that is also known as FTG, or we can use soybean season digest SBCD media, and we will incubate it for 14 days, and then we have to observe FTGB media. It indicates if any growth present in it. It indicates the presence of the anaerobic or aerobic bacteria. If any growth appears on the SBCD media, it indicates the presence of the fungi or either anaerobic bacteria. So absence of any growth in both these media establishes sterility product. There should be no growth on both of this media to pass sterility test for the ophthalmic preparations. And the direct inoculation method is far more simple, in which we use 1% solution, 1 part of the product, and diluent with the 10 parts. Yeah, it would be like 10% of the sterile diluent, and then we will rinse and with any emulsion and media like FTG and glycolate, FTG or soybean gases digest SCD medium. And the criteria is very simple. There should be no microbial growth. Sample is sterile. If there is any growth, sample is not sterile. And the evidence of microgrowth, sample is not sterile. But there should be special consideration that the procedure for the sterility test should also be in a very sterile environment. Because if just consider our product is sterile, but during the sterility test, either our diluent is non-sterile, or either our filtered media is not sterile, or either our containers are not sterile, it can contaminate the product and it gives false positive sterility test. So we should conduct the sterility test in a sterile environment. Criteria for both this number of tests based on the particles batch size. Like if we have 200 containers, then we should take either 5% container, which becomes like 2 containers per batch. So if the batch size is more than 200, then we could take like 10 containers for the test, but it should be like 5% of the container should be tested and pass the sterility test to pass the badge, the sterility test. Then comes the metal particle test. Then how many number of metals are present in our ointment. So this test is also very simple, in which just we take our ophthalmic ointments. It is also performed on the ophthalmic ointment because we don't metals if is present in the topical ointment, metal cannot cross the skin membrane. But if in case of the ophthalmic ointment, we have to consider the metal particle content, because if the metal is directly to our eyes in the ophthalmic ointments, it can do damage our eyes. So metal particle test is the important test for the ophthalmic ointment, performed using at least 10 ointment tubes, in which we takes the 10 ointment tubes and we remove the content completely in the 20 millimeter diameter petri dish. And then what we do, we heat the petri dishes in a closed environment for about 2 hours at 85 degrees centigrade. Once the product is melted, then we will let it settle and cool and solidify. When it's solidified, we will remove the lid, and then we will check the bottom of the petri dish, because petri dish is passed through. We will eliminate the bottom of the petri dish at 45 degree top with the help of a light source, and we will eliminate the bottom surface, and we will observe the ophthalmic microscopic for at least 30 magnification part, and the entire bottom of surface of the ointment is examined, and the number of particles are 50 micrometer above, counted using calibrated eyepiece of the micrometer. Acceptance criteria is very simple. If we are using 10 tubes, then the metal particle count should not exceed 50, and for 10 tubes and for one individual tube, the metal particle count should be 8 particles. And if this test did not meet, then we move further toward the 20 tubes. And for the 30 tubes, the standard is like 150 particles for 30 tubes, and it should for the 3 tubes, 3 individual unit tubes, it should not be for greater than the 8 particles. Then we perform the viscosity test. Viscosity test is also very simple. We use Brockfield viscometer, but the temperature should be same for every viscometry test, and the temperature should be like 20 degrees centigrade, because viscosity do vary with the temperature shift. So we have to maintain the temperature to 20 degrees centigrade, because at 20 degrees centigrade the viscosity of water is 1, and we are using water as a standard for viscosity measurement of the other ointments. So the basic unit is poise, or 100 centipoise. So viscosity is basically the resistance to flow, and it do vary with the temperature. So viscosity do varies the spreadability nature of the ointment. So it's the basic test which is performed on the ointment, because viscosity do increase or decrease with the temperature. So we use basically for the measurement of viscosity, we use Brockfield viscometer, which is here shown in the this diagram. So basically, it is a digital viscometer, in which these are the tubes which moves inside the ointment, and it finds the viscosity. Then the last test is leakage test. It is very simple test, in which what we do, we invert the containers. We take the containers. It is also a test for ophthalmic ointments. What we do, we invert the containers of the ointment, and we check the intactness of the ointments, whether their seal is intact or not. Because if there is an ointment in the tube, it is covered with the aluminum foil. It is totally closed and sealed, and sterile and aseptic. But in case of the ophthalmic preparation, we know there is a seal of plastic present on the container. So we have to consider that the seal of the ointment is intact or not. So leakage test is performed for the ophthalmic ointment. So this is also a basic test for the ophthalmic ointments. So what we do, we horizontally placed over absorbent blotting paper and maintain the temperature like 60 degrees centigrade. 60 degrees centigrade plus minus 3 degrees centigrade. It can be like 57, 58, 59, 60, 61, 62, 63 degrees centigrade. For 8 hours, we invert horizontally the containers of the ointment for like 8 hours on absorbent blotting paper. And if there's any strain absorbed, then the leakage test is failed by the containers, and the seal is not intact. The test passes if the leakage is not observed for any tubes, and if the leakage is observed, the test is repeated for additional 20 tubes, and the test passes if not more than one tube show leakage out of 30 tubes. No leakage means leakage test is passed. So basically, the three tests which are only used for the ophthalmic ointment is leakage test, metal particle test, and sterility test. These are the tests which are only performed on the ophthalmic preparation. So that it's for the evaluation of the ointment. For the pharmaceutical quality management, we will meet soon. Thank you so much for listening.